wave is nothing but it's an oscillatory disturbance. For example, you must have seen water, as if water is there, and if I throw stone in the water, then what will happen? There would be ripples forming in the water. The second stage, I'll give an example. If we consider a rope and I move the rope, what will happen? There would be oscillatory disturbances, and these oscillatory disturbances can be considered as the wave. Now, these are the oscillatory disturbances, but these oscillatory disturbances must travel through the medium. Based on its mediums, we have bifurcated oscillatory disturbances in two parts, means waves in two parts. The very first is mechanical and another that is non-mechanical. So what is the basic difference? There are some waves which require material medium for their propagation. For example, sound. If there is no medium, sound won't be propagated. There are many things happening in the galaxies. You can see stars falling down. Sometimes we can see many happenings, but we do not come to know the sound because there is no medium. Sometimes electromagnetic waves are there, X-rays, gamma rays. So these waves do not require any sort of material medium. That's why these waves are considered as non-mechanical waves. So how will differentiate? Mechanical waves are the waves which require material medium for their propagation, and non-mechanical waves are called as the waves which do not require material medium for their propagation. So what can be the examples of non-mechanical waves? Those are X-rays, gamma rays, and the waves which keep traveling progressively, means continuously. Those waves are called as the progressive waves. But there are some things which we are supposed to look after. The waves, if they want to get propagated, they'll need to be in inertial state. The waves will need to have the medium to be elastic. And now let's see oscillation. What is oscillation? Oscillation is totally new concept. Before oscillation, let's see what is to and fro motion. Let's consider this is the surface or the point from which the waves are supposed to be propagated, and the particle is at the mean position. If the particle is at mean position, then we'll consider it to be in the rest position. Now the particle is moving from mean position A to B, and if the particle moves from A to B, B with the extreme condition, and from mean to extreme, if it is moving, it is called as the to motion. To means what? Forward direction. And if it is coming back in the same direction in opposite way, it is considered to be fro motion, that is backward motion. Means what? In the forward direction and in backward direction. This kind of motion is called as the oscillation or oscillatory motion. Now, if it repeats continuously in the same direction, forward and backward, it would be considered to be the periodic motion. Means oscillatory motion is periodic in nature. Now let's say, what is amplitude? What is amplitude? The maximum distance traveled by the particle from mean to extreme position can be considered as an amplitude.